So let's talk about a real medical puzzle. It's a heart condition that is way more common than you'd think. It can be deadly, and, well, the official story is that it's an inherited genetic curse. But what if that whole story is wrong? What if the answer isn't in our DNA at all? And what if, for decades, the solution has been hiding out in, of all places, a barn?
First things first, let's get a handle on just how big of a deal this is. We're talking about a genuine medical mystery that's affecting hundreds of thousands of people. And a lot of them, they don't even know they have it.
1 in every 500 people. Just let that number sink in for a second. According to the American Heart Association, that's how many folks in the US are walking around with something called Hypertrophic Cardiomyopathy, or HCM. For a serious heart condition, that number is absolutely staggering.
And here's the official line you'll get. It's the most common inherited heart disease in the world. The thinking is, this isn't just bad luck. It's passed down through your family tree. And the really tragic part? It can lead to sudden death, even in young, super healthy athletes who are at the absolute peak of their physical prime.
Okay, so what exactly is the mainstream story here? How does the medical establishment explain this condition that's supposedly hardwired right into our family code?
The condition itself is pretty straightforward to describe. With HCM, the heart muscle gets abnormally thick. This makes it harder and harder for the heart to do its job of pumping blood, until sometimes it just catastrophically fails. And the cause? Well, because certain gene mutations have been found in people with the condition, the medical world points to one culprit and one culprit only: your genes. The answer, they say, is in your DNA. Period.
And you really got to notice the focus here. The whole approach is about management. It's about standardizing care, trying to control symptoms, and screening other family members. The entire system is built on this idea that it's a genetic legacy you just have to live with, not something you could ever actually fix or, cure.
And this is where things take a really sharp turn. What if this entire inherited disease model is just a massive, tragic misunderstanding? What if the medical world has completely missed the most important clue? A clue that, believe it or not, another industry figured out and solved decades ago.
Yeah, you heard that right. Our hunt for answers takes us to a very, very unexpected place: the farm. Because for ages, the livestock industry has been dealing with a condition in their animals that is shockingly similar and just as fatal.
Just look at this comparison. On the left, you have this complex, supposedly genetic human disease. On the right, you've got something farmers call white muscle disease in young livestock. Both involve the breakdown of heart muscle, and both can cause sudden, out-of-the-blue death. I mean, the parallels are just uncanny.
So what in the world connects a human heart condition with the disease in lambs and calves? Well, the answer isn't in genetics at all. It's in the dirt.
I mean, look at this. It's practically a mirror image. The heart muscle damage, the risk of sudden death, the breathing problems, it's all there. But now, look at that last row, the known cause. For humans, it's a genetic mystery. For livestock, it's a solved problem, a simple nutritional deficiency.
See, for farmers, this isn't a mystery at all. They have known for generations that white muscle disease is just caused by a lack of a trace mineral called selenium in the soil and the feed. And more importantly, they know exactly how to prevent it and even treat it with simple supplements. The answer hasn't been a puzzle. It's been standard operating procedure in veterinary medicine for generations.
So, this is where it gets really mind-blowing. What happens when you take this knowledge from veterinary science and apply it to humans? Well, according to researcher Dr. Joel Wallach, the results are nothing short of revolutionary.
Dr. Wallach points to some incredible, powerful evidence. First, there's a condition in China called Keshan disease, which he says is just another name for HCM. It was rampant in children until the government mandated selenium supplements, and then it basically disappeared. Then he connects selenium deficiency to SIDS, pointing out that the rates plummeted after selenium was added to baby formula. And then, the heart-raking case of Reggie Lewis, the Boston Celtics star, who died from this exact condition while being treated by the best heart doctors in the world, and not one of them ever thought to check for a simple mineral deficiency that any veterinarian could have told them about.
So why does it look like it's genetic? This quote offers a brilliant and simple alternative. It's not that families are passing down bad genes. It's that they're sharing the same bad diet, from the same mineral-poor soil year after year, generation after generation.
And maybe the most incredible piece of the puzzle is the story of heavyweight champ Evander Holyfield. In 1994, he gets diagnosed with cardiomyopathy. He's forced to retire, career's over.
But then, he reportedly starts taking selenium. By 1995, doctors declare his heart is back to normal. He's medically cleared, he gets back in the ring, and he does the impossible. He becomes the heavyweight champion of the world all over again. This isn't just a story about prevention. It suggests this so-called incurable genetic disease might actually be reversible.
So when you put all this evidence together, from the farm to public health in China to elite athletes, it brings us to one last really provocative thought. It's a thought that challenges the entire foundation of how we look at this disease.
And this really is the heart of the matter, isn't it? Is hypertrophic cardiomyopathy some unstoppable genetic destiny that we can only hope to manage? Or is it a tragic, massive nutritional blind spot? A puzzle that veterinary science solved decades ago, while human medicine just keeps looking in all the wrong places? The answer to that question could literally change countless lives.